all of these questions on this paper are questions about dilations that have been pulled from previous air tests. Okay, so we're going to jump around a little bit. We're going to skip number 1 for now. We're going to go to number 2, actually. So it says we have 2 triangles, right? Triangle MNO is transformed to create triangle PQR. We want to select all the transformations that would guarantee the 2 triangles are congruent. So we talked a little bit about this yesterday, right? If I am rotating, reflecting, or translating, I'm not changing the size of my original triangle. If I'm dilating, I am changing the size. So for my image and pre-image to be congruent, I just can't be dilating. Right? If I'm rotating, reflecting, or translating, that will preserve the size. So, which of these options then preserves the size? The bottom 3? Yeah, reflection then a rotation, rotation then a translation, and a translation then a reflection. Right? In something like this, all we're looking for is it doesn't have a dilation. Right? Everything else would preserve the size, would make it congruent. Okay? So the first 2 have a dilation. That means the triangles would not be congruent. They would change size somehow. There has been some form of a question like this on the air test for the last 3 years. Okay? So as long as you know that a reflection, translation, and rotation don't change the size, and dilation does change the size, a question like this should be a super easy point on the air test. Okay? And they've also had it just as a multiple choice question. Like, which of these 4 would not preserve the size? Okay? Rotation, reflection, translation, or dilation. Okay? So some form of this question usually shows up on the air test. Okay? Questions on that? All right, then we're still going to skip number 1, so let's jump to the back. All right, so the first one on the back here talks about dilating a line. So we're given the equation of a line, 6x minus 3y equals 5. And I want to dilate this with the center at the origin and a scale factor of 6. So let's get a picture of what this line looks like. Okay, let's plug it into Desmos and see what happens. So, and if you guys want to get out your Chromebooks and put it into Desmos, you're welcome to do that. If not, you can just watch me. Alright, so we've got 6x. You don't have to if you don't want to. You can just watch me. But you can follow along if you would like. Alright, so here is what this line looks like. Okay. They give us, on Desmos, they give us the intercepts, right? We can always click and see the y-intercept and the x-intercept in Desmos. That's one really useful feature of Desmos. We don't have to know anything about how to solve an equation of a line or anything about it. Desmos just tells us the x-intercept and the y-intercept. Okay? Now, we talked yesterday about dilating a point centered at the origin. All we need to do is multiply the coordinates by whatever the scale factor is. Okay? So to dilate an entire line, I'm just going to take a couple of points and multiply by the scale factor. Right? So I'm actually going to move this up a little bit. So if I take each of these coordinates and multiply by 6, right, we can just put that in the calculator. If I do 0.833 times 6, it's actually going to come out to exactly 5, right? But I mean, we don't have to know how to do that. We can just plug it in the calculator. So, and obviously 0 times 6 is 0. So my new coordinate point here is going to be 5, 0. So I'm just taking this point and dilating it by a factor of 6 with respect to the origin. So all I'm doing is multiplying these two coordinates by 6 to get this new point. We're going to do the same thing here. Multiply 0 times 6, that'll still be 0. Multiply negative 1.667 times 6, so that's actually going to be negative 10. Negative 5/3 times 6 is going to be negative 10. Still didn't quite scroll up enough today. Right. So, if I multiply those coordinates, we'll get 0, negative 10. So, once I have those 2 points, I can draw a line between them. And I can draw a line that connects them. And we can do this on Desmos too. Right? We can just put those into the same line with a comma in between them, and then see the line that goes through them. So, there's a couple of things that I can recognize between my old line and my new line. One of the biggest things is that these lines are parallel. They have the exact same slope. So dilating a line does not change the slope. Right? Dilating a line, we will have the exact same slope. Now, what is the slope of these lines? How do I find the slope of a line? Rise over run. So if we're just looking at the graph, I could count boxes. Right? I could go between, I've got 2 exact points right here. I could say, well, I'm going to go up 10 and right 5. Right? Up 10, right 5 would be my slope. So that would reduce. How would 10 over 5 reduce? 2 over 1. Okay. So the slope of my old line and my new line is 2 over 1. Right? Slope did not change. So that's the answer to part of this question. Right? The first part of the question says, what is the slope of the line after dilation? Okay, well, the slope of the line, dilating a line does not change the slope. Okay, so the slope of my original line is going to be the exact same as the slope of the line after dilation. Right now, something that did change, though, was the value of the y-intercept. Right? If we go back and look at our original line, the y-intercept was at 0, negative 1.667, and our new y-intercept was at negative 10. Right? So we needed to multiply the y-intercept by 6 to get our new value. So in this case, my new y-intercept is negative 10. Right? So the slope stayed exactly the same. The y-intercept did change. Okay? So on the homework, there are a couple of problems just like this, where I give you the equation of a line, give you a scale factor to dilate by, and then say, well, what's the slope of the new line? What's the value of the new y-intercept? So once we know the slope of the old line, the slope of the new line is going to be exactly the same, and all then we need to do is multiply the y-intercept by whatever the scale factor is. Okay? Questions on something like this? Right, this is another type of question that has repeatedly shown up on the air test. Okay, so odds are you see something like this on the air test. Okay. No questions? All right, then the next two here, numbers 4 and 5, are pretty similar to each other. Right, this one gives us a graph and the other one doesn't. So let's look at the one with the graph first. So it says, here's triangle ABC. We're going to create a new triangle, A prime, B prime, C prime, by dilating this original triangle by a scale factor of 4. And we want to find the length of my new triangle, A prime, B prime. Okay? Well, first, whenever we're talking about length, okay, given coordinate points, that's going to be distance between 2 points. Okay? So I'm going to end up using the distance formula at some point here. And remember, you never need to memorize this. It'll always be given to you on a test, or, I mean, it's on the formula sheet for the air test. So, one thing that we talked about yesterday is that the length of each side of a figure scaled by whatever the scale factor is. So, for example, if AC has a length of 10, and I change the size of the triangle by a scale factor of 4, the length of A prime C prime would be 10 times 4, 40. Okay? So, all we need to do here is find the length of AB and then multiply that by 4. Okay? I don't have to find each individual point multiplied by 4. I can just first find the length of AB and then multiply that length by 4. That'll be a little bit easier than trying to dilate the whole triangle first. So to do that, we need our coordinate points. So looking at the graph, A has a coordinate point of 1, 4, and B is at 4, 8. So I want to use my distance formula to find the distance between these 2 points. So the square root of x2 minus x1. I guess I should label my points. Okay? Say x2, y2 plus x1, y1. So x2 minus x1 is going to be 4 minus 1. y2 minus y1, 8 minus 4. So we get 4 minus 1 is 3. 3 squared plus 8 minus 4 is 4. 3 squared is 9. 4 squared is 16. And 9 plus 16 is 25. Now, I'm still seeing people telling me that means the length is 25. 5 would be the square root of 25, which is 5, right? We can't forget to take the square root at the end. So, the length of AB is 5, right? This length right here is 5. Well, what I'm doing then is just multiplying the length by 4 to get my new A prime, B prime. So the length of my original triangle AB is 5. The length of A prime, B prime then is just going to be 4 times that. So the length of A prime, B prime is 20. Okay. So on a question like this, we're going to have to use the distance formula to find the length of the original side, and then just multiply that length by whatever the scale factor is. Questions? So then the last one on here, number 5, is the same exact type of problem. They just don't give us a graph. They just give us the coordinate points. Okay. So they give us A is at 1, 1, B is at 2.53, and then C is at 0, negative 3. And then they tell us that our new triangle is dilated by a scale factor of 1/2. We want to find the length of our new side, B prime, C prime. So, to do that, let's first find the length of BC, and then just multiply that by 1/2. Okay, so distance formula, square root of x2 minus x1 squared plus y2 minus y1 squared. So let's label our coordinate points for B and C. x1, y1, x2, y2. So if we do x2 minus x1, we'll have 0 minus 2.5 plus negative 3 minus 3. So, and again, remember we talked about, I could just type this whole thing into the calculator as is, okay, as long as you're using all the correct parentheses and signs and everything. So if you feel comfortable, you can just type this whole thing into the calculator from here, okay? Or we can go ahead and simplify. So 0 minus 2.5 would be negative 2.5 squared. Negative 3 minus 3 would be negative 6. Then negative 2.5 squared is going to be 6.25. Negative 6 squared will be positive 36. Adding those together then, we get 42.25. And then we would need to take the square root of 42.25, which ends up being 6.5. So the length of BC in my original triangle is 6.5. Now to get my new side after I dilate, I'm just going to multiply this length by the scale factor. So now I can say the length of B prime C prime is 1/2 of 6.5. 1/2 of that original length. So 1/2 of 6.5 is 3.25. So whenever we're given coordinates and we're dilating, just find the distance between the original coordinates and then multiply that length by the scale factor. Okay? Questions? Okay, so every year there's usually 2, maybe even 3 questions about dilating on the air test. This is one of the most popular specific topics on the air test. Right? There aren't very many other things